So you should already have notes for that. But lesson 101, problem D and problem E in the practice, because we made it through all the other ones. These were writing equations or writing expressions. So now as we look at D, what is problem D asking us to do? Notice? Yeah, they want us to find the measure of each angle, but if we look at the directions above, it says to do it, they want to see us write an equation. So what do you know about all triangles? They're equal to 180 degrees. So how can I use that information and the information in this picture to write an equation? What do you think, Ty? Yeah, because you're not there in your book yet. That's why I called on you. Where should you be? Lesson 101, we're looking at practice D and practice E. So if we were there, maybe that will help us. What would be an equation I could write using the information they give us? Yeah. Yeah, because I know that all the angles are going to be equal to 180 degrees, so I can take it 2x plus 3x plus x. And I love how you said 1x, recognizing that that's there, equals 180 degrees. They're like terms. Because they're like terms, I'm able to add the coefficients. 2 plus 3 is 5, plus 1 is 6x equals 180 degrees. How do I find out what x is? Divide both sides by 6. X equals 30 degrees. Not what they want as their answer. They want to know what the degrees of all the angles are. So you know what? My angles are x, which is 30 degrees. 2x, which is 2 times 30, which is 60 degrees. And angle 3x is 3 times 30, which is 90 degrees. So x is 30, 2x is 60, 3x is 90. 90 plus 30, 30 plus 60 is 90, 90 plus 90 is 180. I think we're good. Sound good? So looking at E. Yes? We didn't do B? No. We just did A and C? Yeah, he wrote the equation. Gotcha. So we'll go back to B. I couldn't remember it the full weekend. So let's go back. Let's go do E first. It says an online movie ticket service charges $8 per ticket plus a $2 transaction fee. Write an equation that relates the price of buying tickets through this service. Then use the equation to find the cost of 5 tickets. So if we did this in words first, my price is equal to this idea of $8 times my tickets plus a $2 service fee. That should help you come up with what your equation is. Using this information, price equals 8t plus 2. Make sense? And then if they want to know for 5 tickets, what do I do? Yeah, I say that t is 5. Price equals 8 times 5 plus 2. Price equals 40 plus 2. Price equals 42. So we get this idea of $42. And if we did not do B, let's go back and just finalize problem B. To finalize problem B, it says 10 less than half what number? You were told to write an equation. 10 less than half of a number means we're taking away 10 from half a number. So half of a number minus 10 should have been what you came up with is equal to 30. How would you solve it? What's the first thing you're going to do to solve it? How do you do on the equation? I'll give you an equation for E. Okay? Okay. What do I do to solve this? This is tomorrow's lesson, actually. Yeah, because we have this term here is my x term, so I'm going to add 10 to both sides. So half of x equals 40, multiply by 2, x equals 80. X equals 80. So any questions with that? Excellent. All right, so I want to look at the beginning of lesson 102. We're not going to take notes on all of 102. We're going to look at the beginning of 102. Beginning of 102 is transversal. Transversal. A transversal, by definition, and we did these last year, is a line that intersects two or more other lines. A line that intersects two or more other lines. Now what we're going to focus on, our focus, and probably the most valuable, our focus, is a transversal of parallel lines. That looks like a terrible way to spell parallel. I think it's only one R and two L's instead. Yeah. P-A-R-A-L-L-E, parallel lines. Our focus is a transversal of parallel lines. So, what that would look like, a little bit. All right, good. We're going to take a line here, take a line here, give that an arrowhead, give that an arrowhead, arrowhead, arrowhead. This one right here. All right. A, B, C. So now from that little image right there, we know a couple things. I know that A is parallel to B. C is a transversal. How many angles are created when we do this? Yeah, 4 on each spot. We're going to create 8 angles from doing this, okay? Now, if I come through and I number these angles, let me number them exactly the same way the book does. 1, 2, 3, 4. Okay. The book numbers them this way. 1, 2, 3, 4, 5, 6, 7, and 8. Now, what we end up doing is we end up giving some relationships between some of these. 1, 2, 3, 4, 5, 6, okay? And what we're interested in is some of the things that we know. If I look at angle 1 is an obtuse angle. What other angles would be equal to that? The measure of angle 1 equals, what other angles? Measure angle 5. Also equals? Yep, and? Very good. Now, I really like that you said number 1 and number 5 first. Do you remember from last year what the name of those two angles would be? Angle 1 and angle 5, because they're in the same spot on these two things. You remember the name of those? That's what we're going to look at. Those are corresponding angles. Maybe that'll ring a bell. We'll define it in just a little bit. Also, as we look at this measure of angle 2. If I look at measure of angle 2, what other angles are equal to angle 2? Measure of angle 6. And you did a corresponding angle as well. And then? And? Measure of angle 3. And measure of angle 7. Now, what's nice about this is because they are parallel, they're going to be the same. So when I look at this one right here, and I'm going to come back to my pen, and I'm going to say this angle right here is 70 degrees. So the measure of my small angles would be 70 degrees. Every single one of them is going to be 70 degrees. Does that make sense? So if that one is 70 degrees, how much are the obtuse angles? Because there's supplementary angles, so 180 minus 70 is 110. Okay, so far so good. You remember a couple things. Now what I'm going to put on the board are a couple of different names. Our book doesn't have all the names that we learned last year. They do have some of them though. So let's look at a couple of them in this one. And let's go with the word corresponding. Corresponding. Now these are corresponding angles. Okay? Corresponding angles are angles created on two different parallel lines that are in the same relative position. Angles created on two different parallel lines that are in the same relative position. In other words, they're the corresponding parts. And naturally, you guys came up with those. So examples would be angle 1 and angle 5. Angle 2 and angle 6. Angle 3 and which angle? Angle 7, good. And then angle, what's left? 6? Nope. Angle 4. Which one's in the corresponding part? Angle 8. Those are corresponding angles. Okay? Now, the other ones that they give us in this book, alternate exterior and alternate interior. Alternate exterior, alternate interior. So by alternate, we're talking opposite sides of transversal. I'm going to put that on both of these. Opposite side of the transversal. Exterior is going to be outside the parallel. Outside parallel lines. Interior is going to be inside parallel lines. Equal in measure. Equal in measure. I'll give you a chance to get that down. Opposite side of transversal, outside of parallel lines, equal in measure. Alternate interior are going to be opposite side of transversal, inside parallel lines, equal in measure. So, if I look at the exterior angles are going to be 1, 2, 7, and 8. Does that make sense? Because exterior is going to be outside. So, let me use examples here. I'm going to underline this or put a box around this because these are my examples. I'm going to use red for this one now. Angle 1. Opposite of the transversal, same measure. Angle 1 and angle 8. Don't circle them, but you can see this one and this one. It's opposite of the transversal, same measure. It's on the exterior outside. So the other alternate exterior would be what? 2 and 7. So what do you think alternate interior angles would be? Let's start with angle 3. Angle 3 and angle 6. Opposite of the transversal. And then angle 4 and everybody? Angle 4 and angle 5. So those are the angles that your book spends the most time talking about. Alternate interior exterior. Last year you had some other ones. Might have been during COVID. Let's define them real quick though, just so we have them. Adjacent. Adjacent angles. Adjacent angles. They share a vertex and a side. Okay, these guys are next to each other. So when I looked at this, the angle 1, there are 2 angles that are adjacent to angle 1. What are the 2 angles adjacent to angle 1? Angle what? Yeah, because here's a vertex. Angle 1 shares this side with 2 and this side with 3. So angle 1, angle 2, and angle 3. They are adjacent angles. So we'll just do one more. We'll say angle 8. What 2 angles are adjacent to angle 8? That's it. Angle 7, angle 6. So those are adjacent angles. And we'll do one more. Vertical. Vertical angles. Again, not in your book this year, were in your book last year. Vertical angles, they share a vertex. Share a vertex. They have the same measure. And they're formed by crossing or intersecting lines. Another name is opposite. Another name is opposite. Okay? So my examples here, I'll tell you one of them. Actually, from that definition, if I said angle 1, which angle do you think is a vertical angle? Angle 4. Here's my crossing lines. Here's the vertex they share. Angle 1 and angle 4. Angle 1 and angle 4. Very good. Angle 2 and? Angle 3? Angle 5 and? Perfect. Angle 6 and angle 7. All right. So I'm going to